Okay, so to summarize. Welcome, everyone, to another episode of Ben's MicroVision podcast, a podcast for general information and entertainment purposes only, not a financial advice podcast. If you're new here, my name's Ben. I was MicroVision's global product manager for wearable displays between 2006 and 2011. Now here, 14 years on, I've maintained my love for the company, and I am seeking to bring you the very best MicroVision related information that I can. So towards that end, if you would, please do go ahead and subscribe to the channel if you haven't already. Give it a like, share with your friends, and do all that stuff that helps the YouTube algorithm pick up the show and broadcast it out to a wider audience. That'd be wonderful. And welcome to episode 22 of Ben's MicroVision podcast, titled America's Sensing Layer, presented by myself and brought to you by LaserRoasted.com. This is my specialty coffee company where the beans are roasted to order, giving you the freshest, most aromatic coffee that you've ever had, I guarantee. And we also have a variety of delicious jerkies that you can try, and so far people are really loving it. This is a disclaimer. The disclaimer is intended to help you know that even though I used to work for MicroVision, I have not for some time, and I'm not representing MicroVision, and they don't endorse necessarily anything that I'm saying here on this show. Everything that I'm talking about is based in the public domain, and I do my best to give you the most accurate and up-to-date information I can. In the event that mistakes are made, this is possible and could happen. And in the event you make a decision based on the content of this show, that is your responsibility and not mine. In a very significant event in the world of autonomous vehicles, General Motors announced their plans to produce a Level 3 eyes-off driving vehicle for 2028. GM has had a long and sometimes troubled history with automated driving systems. Some of the earliest proposals date back to the 1950s. But the efforts at GM R&D really took off in the 1990s when the automaker participated in a test program in California that had vehicles driving on a highway and following beacons embedded in the roadway. In the mid-2000s, GM engineers supported the efforts of the team from Carnegie Mellon University that took part in the DARPA Grand Challenge. The CMU entry, a Chevrolet Tahoe called Boss, ultimately won the Urban Challenge in 2007. Interestingly, IBEO was part of that winning team with Carnegie Mellon and GM for that Boss vehicle that won the DARPA Urban Challenge. Many of the members of the CMU team, along with the rest of the DARPA competitors, went on to be key members of programs at Google, Zoox, Motional, Aurora, May Mobility, Cruise, and others in the automated driving ecosystem. GM acquired Cruise in 2016 and made it responsible for its automated driving programs, including developing a robotaxi service. At the same time, through the 2010s, GM developed its hands-off, eyes-on Super Cruise system that debuted in 2017 and is now offered on 23 GM models. That system allows drivers to get hands-off on nearly 700,000 miles of roads in North America, while it manages speed and keeps the vehicle in the lane. However, it requires constant supervision by the driver. The next stage in the evolution of this system is scheduled to debut in 2028, with the driver being able to go eyes off under certain conditions. What else happens in 2028?
2028 launch. These are targeted to be $200 or less in the corners, $300 for long range.
This next-generation system is being developed by a combination of the existing GM-assisted driving team and former Cruise engineers. These hands-off, eyes-off systems fall under what SAE International defines as a Level 3 or L3 conditional automation system. So far, Honda, Mercedes-Benz, and BMW have launched L3 systems, but they are very limited in their capability. The Honda system was only sold on a small number of cars in Japan, while the German systems only operate at speeds up to 37 miles per hour on highways in Germany, with the Mercedes system also available in California and Nevada. Other companies are developing L3 systems, including a new system from Honda in the next couple of years, as well as a Mobileye system coming to some VW Group models in 2027. The GM system is the first that we know of that will be able to be used across North America. GM hasn't yet provided details on how it plans to overcome the legal approvals to use the system more broadly than other current systems. While most details of the GM L3 system, which still doesn't have an official brand name, are limited so far, we do have some information. The system is developed entirely in-house at GM and will be the first product from the automaker to move over to an NVIDIA compute platform. The system will debut on the Cadillac Escalade IQ, and that will also be the first vehicle from GM to incorporate a new centralized compute electronic architecture rather than the domain controller setup used on current vehicles. This will simplify the architecture, reduce wiring needs, and make it easier to do over-the-air software updates. The L3 system will rely on a mix of cameras, radar, and Lidar for sensing. While it will initially be limited to highways, as Super Cruise was at launch, the goal is to expand the operational domain to urban and then eventually Level 4 autonomy. For an L3 system, the driver is required to remain awake, well, that's good, and at the wheel, so they can take over when the system reaches the limits of its capability. They can read, text, or watch a movie, but can't take a nap or get out of the driver's seat. If and when the system reaches L4 capability, the driver can take a nap. The new electronic architecture will enable fully capable software-defined vehicles that can add new capabilities over the life of the vehicle. While it will debut on an EV, it will also be incorporated into internal combustion and hybrid vehicles in the future. Okay, in another article on the same topic from Inside EVs, it's reported GM plans to add eyes-free functionality to Super Cruise by 2028. It would be a true Level 3 advanced driving assistance system, one step up from the Level 2 system that currently defines Super Cruise and virtually every other system in the US. The Escalade IQ will do so with the addition of Lidar, or light-based radar, making it a considerable technological leap from its current camera, radar, and GPS-based system. That system will then spread to more GM models very quickly, CEO Mary Barra said at the event. We now have standard Super Cruise on 23 models, and we did that quite quickly once we could, Barra said, noting that its pace was slowed by the pandemic-related chip shortage. This is something you'll see us roll up much, much faster than Super Cruise. GM officials have not disclosed which company is supplying its Lidar array, but over time, GM's autonomous technology will move off of highways as well. From there, we'll expand to urban environments, ultimately enabling your vehicle to handle errands while you focus on more important things, said Sterling Anderson, GM's Chief Product Officer. We'll build incrementally and we'll deploy safely because we know this works. That's the only way this works. In making the announcement, GM seemingly took a shot at Tesla's camera-only approach to ADAS. Unlike vision-only systems, GM's approach is built on redundancy with Lidar, radar, and cameras integrated into the vehicle's design, the automaker said. At the core is sensor fusion. The Lidar, radar, and cameras build the perception layer. Real-world driving data trains the decision-making model, and high-fidelity simulation validates performance across rare or hazardous scenarios. This provides a safe, reliable, and highly capable eyes-off autonomous system. So there you have it. The largest automaker by market share in the United States is saying they're going to be rolling out vehicles with Level 3 automation using a Lidar array in 2028. Here's a list of the top American vehicle OEMs and the key brands that are sold into the United States, including GM at 2.7 million units sold last year, Ford at 2 million units sold last year, Stellantis with the U.S. brands. This is a Dutch company, but the U.S. brands include Ram and Jeep and Chrysler, and they sold 1.3 million units. And then there's Tesla at an estimate of 634,000 units in a year. So here's each of those 4 OEMs and their approach to autonomy as it's been most recently discussed by them. Ford recently came out and said Lidar is mission critical. Back in June, I think it's episode 6 of this show, I did a whole show about Jim Farley talking about Lidar's mission critical. So I think they were in talks with Tesla about potentially licensing the cameras only full self-driving. They thought better of it and decided they would go with a Lidar-based approach, and so they declared Lidar as mission critical. Now, they have not as yet, as GM has just done, announced which model year and which car it's coming in on, but they've declared their intention to use Lidar for autonomy. Here's a statement from Mary Barra. This is something that you'll see us roll up much, much faster than Super Cruise. So not only are they going to use a Lidar array on the Escalade IQ, but the intention is put it on as many vehicles as possible, as fast as possible. Here's Stellantis' commentary. They had their own Stella Auto Drive concept that they were really working hard on, but then pivoted and changed their mind and abruptly stopped. And they decided, we're going to work with select suppliers to ensure access to the best technology at competitive costs. So we don't know where they're at, but we know they're not going to do it the way they originally thought to do it. And then there's Tesla, cameras only, dead enders. Okay, so for the sake of making a forecast, we can assume that the total U.S. vehicle sold rate, which is right now 6.1 million, will grow at a 4% compound annual growth rate between now and 2028, which would give us a figure of 7.2 million cars sold into the United States. If by 2028, 1% of those vehicles sold includes the MicroVision Tri-Lidar solution, then that would mean there's 72,000 vehicles equipped with the Tri-Lidar Lidar array. At $700 for the 3, that would give MicroVision revenue of $50.4 million in 2028. As the volumes grow, you get the benefit of the growth in automotive sales, and theoretically, they could grow the penetration rate into Ford, GM, Stellantis, and probably not Tesla, but maybe. So if they grow from 1 out of every 100 cars featuring the Tri-Lidar, which would get us 50 million, to 3 out of every 100 cars, now you've got 157 million in year 2, 233 million in year 3 if we get to 5 out of every 100, 7 out of every 100 cars gets you 340 million, assuming we drop the ASP to 600, and then by 2032, 5 years into it, maybe it's 10 out of every 100 cars has a Tri-Lidar architecture. Maybe we brought the price down to $500. And now you're at $421 million in the U.S. alone by selling Tri-Lidar systems to Ford, GM, Stellantis, and getting 1 out of every 10 cars equipped. Now, will 1 out of every 10 cars have a level 3 capability by 2032? Or will it be much, much higher? Well, that's for you to decide. Oh, let's take a break and check in with the laser-roasted kaiju mascot in his quest to provide the freshest coffee on Earth. this week. For orders of $50 or more on laserroasted.com, be sure to apply the discount code MVIS10 at checkout and take 10% off your order. So just for clarity, the forecast shown earlier of 7.2 million vehicles sold into the U.S. is a forecast that includes only GM, Ford, Stellantis brands such as Jeep and Ram and Chrysler, and Tesla. So the reality is that there are many foreign-made vehicles, including Toyota, Hyundais, Kias, Hondas, that are sold into the U.S. every year by the millions. So the total volume of U.S. vehicles is going to be higher than that. I think the point that is of interest is that it's kind of a binary thing. If you win the deal with the OEM, then you get to provide the capability for autonomous driving to that OEM across their fleet. And when you listen to Mary Barra say she's going to proliferate that broadly as fast as possible, much faster than Super Cruise, I think these OEMs see that the autonomous driving level 3 capability is very, very valuable to the end users. And it's going to be the kind of thing where if your car doesn't drive itself, it's considered, a relic. So we can look at forecasts that say 1, 3, 5, 7, 9, 10%. But realistically, there's only a handful of these OEMs. If you win one and they've got 16% of the market, well, those numbers could start to accelerate. So I put this list together a few weeks back when Glenn got hired as CEO, and we can see the Lidar company CEOs all arrayed here. One of these companies is going to win this deal with GM and proliferate their Lidar across GM's fleet. So the question really is who? Is it Ava? Well, Ava's got FMCW architecture, which is more costly and complex than MicroVision's time of flight, for example. So is a more costly and complex LiDAR system going to become an array of costly, complex LiDAR systems across GM's entire fleet? Your guess is as good as mine. But in episode 6 of this show, I put together a detailed analysis and comparison of their architecture versus the MicroVision architecture, and you can evaluate that. Luminar has all kinds of drama and intrigue playing out inside the boardroom there, where Austin Russell, who was ousted for an ethics problem, is now colluding with other board members to, I guess, buy out the company and probably replace the CEO. And so who even knows what's going on there? Innoviz is trucking along. They're doing their good work trying to get into robo-taxis and partnerships with Mobileye and stuff like that. And then there's MicroVision, which is going for low-cost, mass-market capability with the low price point and the high feature set. So we'll see. So last week, we talked about JP Morgan Chase and their initiative to support U.S. resiliency with a $10 billion set of investments that they'll make directly, and then an additional $1.5 trillion, I'm not sure where that money's coming from, but over the next 10 years. So let's just call it a significant amount of money is going to be deployed by JP Morgan Chase in an effort to support U.S. resiliency and national security by investing in companies that provide critical capabilities across these 4 areas: supply chain and advanced manufacturing, defense and aerospace, energy independence and resilience, and frontier and strategic technologies. As I pointed out last week, sensor hardware and edge computing are both called out as the select sub-area of interest for investment. So, just doing the numbers roughly, if there's $10 billion available from JPMC and there's 27 sub-areas, then each sub-area is worth about $375 million. So now are they going to equally apportion the $10 billion across 27 and, give everybody an equal slug? Probably not. But we could say there's hundreds of millions of dollars in JP Morgan investment available to American companies operating in these 27 sub-areas, right? Sensor hardware and edge computing are areas where MicroVision plays. And they're areas where MicroVision has a significant technology advantage and a great history of providing capabilities and technology to the U.S. government. And a story could be created that makes MicroVision one of the more attractive investments, potentially, for JP Morgan to consider in an effort to support the U.S. national resiliency and national security. So for the remainder of the show, I'm going to walk through how MicroVision is America's sensing layer and how this can help America's national security and resiliency. The missing layer of national resilience. America is building a digital infrastructure for finance, energy, mobility, and defense, but it lacks a unified sensing layer that makes the physical world machine readable. MicroVision provides a foundation for that layer with laser-based 3D perception at the edge, where decisions need to happen instantly. The next frontier of resilience, from autonomous logistics to border security, depends on trusted American sensing technology. MicroVision originated as a Department of Defense supplier doing leading-edge work in laser-based scanning systems. And these systems are designed for soldiers, airmen, people in battlefield-type situations. Okay, all the way back from 1993 to today, MicroVision's provided optical, laser-based systems to help our soldiers be safer, more accurate, and perform better on the battlefield. That same optical mastery has now been converted to serve a new modality, which is sensing. And the Lidar and edge perception sensors, which can survive harsh conditions, they can deal with vibrations, they can handle signal interference. Okay, these are rugged, hardcore sensors. And what they've done is they've gone from the type of engineering that's required to provide capabilities into the military, and they've distilled that into a commercially scalable type of technology and platform. So here's the trick, and what may be of particular interest to JP Morgan, since they called out both sensor hardware and edge computing, which is that MicroVision provides both. They are not just capturing data with the sensors, but on the same chip, they're interpreting what the scene means, and then they can decide what's the next right action to take based on that. So since the sensor has built-in edge computing, that means there's lower latency, improved security, and reduced cloud dependence, which is critical for defense and infrastructure applications. So JP Morgan's got a security and resiliency initiative, and this fits that mandate for localized sensing and decision systems that minimize central vulnerability. So it's all about U.S. national security and making sure that we're able to function whatever the situation might be. And having a sensor with built-in edge computing that can not only read the scene but interpret the scene as it's happening from a trusted American provider is pretty important. MicroVision provides high-fidelity 3D mapping with the lowest power, the smallest size, and the lowest cost in the industry. The proprietary MEMS scanning or the sequential flash architecture, when coupled with the custom ASICs, can generate very dense 3D point clouds at a fraction of the power consumption of legacy mechanical spinning LiDAR systems. This is vitally important for all of the markets we may wish to serve, but particularly for autonomous vehicles, logistics robots, perimeter defense, and smart infrastructure. MicroVision is a trusted American supplier headquartered in Redmond, Washington, not in Shenzhen or Shanghai. MicroVision is one of the only US-based full-stack LiDAR and perception providers. And we understand what can happen if a Chinese-made LiDAR gets onto U.S. roads or gets into U.S. infrastructure. Those companies are bound to deliver information back to the Chinese intelligence services whenever they want it. So this is just not a situation that we can really allow to happen. And I know the administration is going to make sure that that doesn't happen. So having a trusted U.S. supplier of this sensing and perception capability is going to ensure that all the critical United States systems see through trusted American eyes. When we talk about national resiliency, what we're really talking about are systems that can perceive independently and remain functional, even if networks or GPS systems fail, which is critical for autonomous defense, emergency response, and American infrastructure. So the Lidar and edge perception embedded on the chip provides redundancy and security at the hardware layer. Here's something for you to consider. Automotive Lidar is just the first commercial path. The larger opportunity is a nationwide perception fabric. Think about ports, substations, warehouses, airfields, autonomous convoys, all sharing a common sensing backbone. MicroVision's Lidar and perception software are ready to deploy across these environments today. MicroVision software and firmware collectively define a common language for sensing and perception, standardizing how different platforms acquire and interpret 3D data. It's the same kind of interoperability that the internet had with TCP/IP, now applied to three-dimensional spatial awareness. The U.S. needs that kind of consistency to secure multi-domain operations. It's a matter of national competitiveness and national security to control your own sensing layer and control the future of autonomy and defense within your nation. The U.S. cannot rely on foreign-made optics or perception stacks to provide this capability, and MicroVision, as a trusted U.S. supplier, can do so. Hopefully, as time goes along, we'll start to see some traction in the defense space for MicroVision sensing and perception capabilities, which of course would lend a lot of credence to everything that I just went through. So we can look forward to the story strengthening and that credibility building as MicroVision acquires some commercial wins or wins in the defense space that would underpin a larger story like I was just weaving. I think that's going to do it for this one. Thanks so much for sticking with me. Please do like, subscribe, add a comment. Comment here on the YouTube channel because that's what YouTube picks up on to drive the algorithm and share the video to more people. So that would really be great. We're going to take you out with a little extended ending, some new music that I just came up with and just recorded earlier this week. I really hope you like it, and we'll look forward to seeing you again on Saturday.